I am. Hello, hello. Oh, this is so wonderful. Okay. Oh, I am going to be talking to you about something that is great. Oh, you won't believe this one. I'm going to be talking about quantum money and not the kind of videos that you see in the internet, they don't know what they're talking about. I'm actually going to be talking about scientific, the scientific concept of quantum money. Okay. This is wonderful, okay? Don't go anywhere because this is a magnificent opportunity to start a new company in the future, okay? If you're like under 20, oh, this is the thing, okay? Um, right now, right now is the moment to learn these things because, okay, all these things are going to be very, very, very important, and companies are gonna emerge of all these things in the future. Just so you want to stay right here, you're gonna watch this one all the way through because I'm gonna tell you, okay? The secret, a little secret, okay, on how to make a company. Okay, I'm gonna share this secret with you, and when you start your own company, please hire me. Okay, uh, and I will teach you right here. I'm gonna be showing you right there. Okay, all this stuff. Okay, so that when you start your company, oh, I'm gonna be old. Okay, like I don't know, like 70 or something. You're gonna be like, I don't know, like 30. You're gonna be building this company. You're gonna be issuing quantum money. Let me explain. Okay, the idea of quantum money came about in the 70s, early 70s, more or less. Okay, and the guy, okay, you can imagine the guy tried to publish the paper and nobody believed him. Okay, and nobody wanted to publish his paper. It was in the 80s when finally something came about. Somebody actually accepted a paper for publication together with other people. The idea that he had was like, okay, if I have all these little quantums, okay, in different states, well, I can verify them if I measure them properly. If I don't measure them properly, they get destroyed. So he thought, okay, these can be used as quantum money because this is money. Listen to this, okay? This will be a wonderful company. This is money that you can only verify, but you cannot copy. Money that you can verify, but you cannot copy. So our government right now, okay, all governments from all nations that have a currency, they try very hard, okay, to make sure that nobody's copying bills, okay, making false bills roaming around. And that's why people have to check them all the time. But imagine this is money, okay, that has a serial number. And with that serial number, you can verify it. And this money it cannot be copied. Think about that, okay? Isn't that an advantage? Well, right here, this screen, you and I, okay, we're gonna build, or we're gonna make our first quantum money, okay? We're gonna issue our quantum money. So we're gonna play a little game, okay? You and I are gonna open this company, okay? This company. I'm old, okay, and you're very young, okay, and and in this company, okay, you and I are going to verify the money, okay. So this is how it's going to work, okay. In this future, people are going to have quantum money in some vault, like frozen, okay, and they are going to transfer that money to another vault using some quantum internet, okay. But in between, there's going to be an agency that verifies that, okay, and that agency is going to be the bank, okay. Let's call it the bank, and of course, there's going to be a central bank that issues the money. All right, so our job, okay, in this company is to take the money and measure it correctly to verify that it indeed is what it's supposed to be. Okay, so every dollar in this world is going to have a serial number, and we're going to take the serial number, and that serial number is going to be used that to verify. Okay, to verify that in to verify to use the correct measurements to verify that indeed it is what it is supposed to be, right? And so let's do that, okay? Ooh, this is exciting, okay? Don't go anywhere because this is the company. This is the company that you want to open, okay? When very soon, okay? This is the moment, okay? So don't miss this wonderful opportunity with this education that you're gonna get right here. Okay, notice below I got 6 qubits, okay? Typically, you want to make money okay, quantum money, with a lot of qubits because you want to make it very difficult to copy that money, right? But we're going to start with 6 because that's what we got here. Actually, I can get up to 16 in some of the quantum. So keep in mind, I'm right now connected the IBM quantum platform. So this is actually connected to a quantum computer, all right? So we can actually run this one, okay? We can actually get, for the first time, just for a very short amount of time, one of those dollar bills before he becomes decoherent, okay? But we're gonna create one right now in a very theoretical way, all right? So I came up with my dollar bill. You see that sequence? That's gonna be our dollar bill right there. 101 plus negative 01. Okay, so for 1 and 0 in this sequence, we're gonna use what we always use for 1 and 0. Okay, the qubits are already 0, all of the ones that you see right there. So if we flip them, it's gonna become a 1, right? So the first one is 1. 1. So the first one right here, I'm gonna put a flipping gate right there. Okay, so that's going to flip the 0 into a 1. And then the next one right here, this one is a 0, so we're gonna leave the next qubit alone. Then the next qubit is 1, so we're gonna use another flipping gate right there. Okay, very good, we're getting there. Now notice there's a plus and a minus. Okay, we're gonna define the plus, okay, as a superposition state of the qubits on the z direction. Okay, now remember, a lot of these qubits right here are in two directions, the z direction, up or down. Okay, up or down. All right, so 0 and 1, 0 and 1. Now the h, okay, puts it in a superposition state, kind of like up or down, kind of like that. All right, that's how I like to imagine it. Now another way to represent that is along a different direction, the x direction. Okay, so instead of doing this, I can just represent it as like that. Okay, so think about that h right there as being in one direction, in the x direction. Okay, and for the next digit in my dollar is a negative, and for a negative, I'm gonna do it like this. Okay, I'm gonna put right there a flipping gate, and I'm gonna put a Hadamard gate. Okay, right there. Okay, that's gonna be the opposite. All right, good. So we're almost done issuing our money. The next one is 0, so I don't do anything to the next one. And the next one is a 1. So I'm gonna so I need to flip the last one. There you go. Okay, good. So, wow, we created our first dollar bill in this quantum money. And if I actually hit run over there, somewhere around there, the computer actually starts putting it all together, the IBM computer, and it gives us the results. Okay. Now, here comes the tricky part. This is the part where we're playing the central bank that is creating the dollar. So we created our first dollar. Now we're gonna do the verification. Now this is where it gets tricky, okay? Because this is what we gotta do. We gotta verify that dollar bill right there. And the thing is that qubit dollar, okay? Qubit coin. Yeah, let's call it qubit coin. Let's get that qubit coin and let's verify it. And the thing is, in order to verify that, we have to measure it right. Think about that. Okay, we got in this money, we got two directions: the up direction, the down direction, and the x. Okay, and the other x, right? Okay, so we got two directions: up or down, right and left. Let's put it like that. Okay, as you can see, that corresponds to what is right here. If we don't measure it correctly, okay, what we're gonna do is spoil the dollar, and we're not gonna be able to do anything with it, right? So somebody, for instance, tries to see what's in that dollar, somebody that is not the bank, and say, hey, you know what? I'm gonna take that dollar and I'm just gonna copy it. I'm just gonna do that. That person needs to know exactly how to measure it, okay? Because if the person doesn't know how to measure that one, it's just gonna destroy it. So if he tries to use it, thinking that that person just got copy a dollar, it's not gonna work, okay? So what we're going to do is, remember, I told you at the beginning, every dollar has, every qubit coin has a serial number. So that serial number is going to tell us what to do with that qubit coin. All right. Pay attention to this one because hey, this might be the next thing for you. The thing that this might be the thing that makes you wealthy. Okay. We just put together one dollar bill in this fictitious world, right? That could be true. All right. So now we're going to try to measure it. Now notice the first qubit. It's in the z direction. So the serial number should tell us that the first one is in the z direction. So we're going to measure it in the z direction. So what I'm going to do is I'm going to measure the first one in the z direction. Okay, that's what I'm going to do. So I'm going to go, see if I can make that one smaller. There you go. So I'm going to take z right there. Is that the z? Oh yeah, z. And I'm going to put it right there. Okay, good. And the next one is in the z direction. So that's what the serial number is saying. Okay, the next digit is in the z direction. Okay, we still don't know what it is, but we know that the serial number is saying how to measure this. Okay, z direction. Let's get it in the z direction. Bam, there you go. Is the next qubit in the z direction? Yes, it is in the z direction, right? There is no h. Okay, there's no superposition state right there. So we measure it in the z direction. Okay, and this is where you're careful. You have to make sure that you measure things in the proper direction. So notice the next one is it's a superposition state. Okay, it's like this. It's not in one particular direction. It's in both. So if we measure in the z direction, we might get this one or this one, right? Sometimes this one, sometimes this one. And we don't want that one, right? It's got to be one or the other, right, for an actual bill, okay? And we said it's in order to speak of one particular direction, definite one particular direction is this one, okay? So how do we measure in this direction? Well, I'm going to tell you this. The IBM platform doesn't measure in direction other than the z direction, but here's a little hack that you can try. What I'm going to do, okay, what I'm going to do is I'm going to translate this direction as in this direction or this direction. So I made it right here. So notice below I rewrote the same number, but instead of writing a plus, I put a 0, okay, because the plus is going to be a 0 in the z direction, and the negative is going to be a 1 in the z direction. So in order to do that, to do the transformation, right, from one to the other, I'm going to add a little, I'm going to do a little hack right here. I'm going to put an h right before I measure it. So I'm going to drag the h, put it where the h is, right? Okay, so I'm going to put the h right there, okay? And then I'm going to slide this one very carefully because I can disrupt the quantum system. No, it's kind of hard to press it. There you go. So I'm going to go this way. And notice the next one is also, and then I'm going to measure it. I forgot to put this one. I'm going to drag that one right there. Okay, there you go. Now we're good. Now we're measuring in this direction, we're translating this one to one direction. The first one is, so the plus is a 0, so now we're like this, okay? Just by doing that little hack, a little trick. And then the next one, okay, the next one is also has an h, so we're gonna put another h, right? So I'm gonna move my head right here, put the h right there. Okay, cool. And then I bring another z measurement. Okay, ooh, we're almost done. And the last one is, see if I can slide up. Oh yeah, this way. There you go. Let me see if I make sure I don't disturb the system because I did it before. I press it. There you go. Okay, let's verify. There it is. Okay, the next one is in the z direction, so I'm gonna put another z right there. Okay, let me see if I can make it small without pressing something that I don't want to press. There you go. So I'm gonna put this one down there. There you go. Nice view, huh? Now you can see the whole circuit below. I'm gonna take the z right there. See, there are z's right there. There are no h's. So I put one right there and one right there. Okay, cool. Now we're ready. So if if I verify the dollar bill that I have right there, I should get these numbers below, right? I should get 1010101, right? So that's what we're gonna do. So I'm gonna do a theoretic. I'm gonna run this theoretically. Okay, there's a function right on the top that allows me to do that. Right there, that's a good space. I should check my circuit just to make sure I didn't move something by mistake. I think everything is in its place. Yep, yep, yep. Everything looks awesome. Uh-huh. Ooh, okay, I think everything is in its place if I didn't move it by mistake, so I'm gonna view that one. I'm gonna look at the probabilities and oh, there you go. Ah, look at that. We got the same number. We got let's see, 1010110, and that's exactly what we got right there, right? Oh, that's so we're verifying the bill. As simple as that, right? We say that that bill is legitimate. Now, let's imagine that we somehow see the serial number, but we don't know how to go from the serial number to verification, which is what a person wouldn't have normally. They wouldn't know how to go from one to the other, right? So let's say they just put something random right there. So that's what we're gonna do. Let's try to mess it up deliberately. We're gonna try to copy this bill. we don't need we don't need all of this stuff. Come on, they don't know what they're talking. So somebody can think, well, I don't need to. I can just measure all in the z direction. What would happen if I just measure all in the z direction? I mean, what difference does it make if I don't measure it like this? Okay, like this. Let's just measure all along the z direction. Well, you're not gonna get the same results, and I want to show you that. Let's measure everything along the z direction because. So let's see. What I'm going to do is I'm going to get rid of that one right there. Let's see if I can hit it right there. There you go. Go away. There you go. Now we have everything in the z direction. So anybody trying to fake the bill, they go like, well, I'm going to figure out what's in there. Let's copy. So let's run it now like that. Let's do a theoretical run of this circuit. View and measure. There you go. Notice what happens. Notice what happened. Okay. Now you don't get just one possibility. You get a bunch of possibilities. Okay. So as you can see, if somebody tries to copy this bill, now this person is going to have to face not just one possibility. Now you have many possibilities. So this person will be like, why am I'm running this one several times and I keep getting different answers. Why is that? Okay, well, there you go. Because you're not measuring in the proper base, right? And even if the person picks one out of those, maybe the wrong one, right? Maybe the wrong one. It's especially, and that it becomes very unlikely to copy if you have a lot of qubits. Imagine how many columns you would get there, right? So it's very difficult to copy a bill if you don't do it the right way, right? So just doing that, just putting a bunch of Z's just the way it is right there, that's just not gonna do it, right? Because you have to know you have to take the serial number, and that serial number in this company has to say how to measure it, okay? And if you measure it right, then you're going to get something that is valid, right? Something that corresponds to that particular bill, right? So in our case, we're supposed to get this. We get something different from that. Well, this is a fake bill. Call the police, okay? Because this is a fake bill. So this is quantum money, okay? And think about this. This is a wonderful way to start a company. Seriously, right? One of the problems that you can have, the one of the physical limitations right now is making sure those qubits are coherent, right? Because if you're gonna keep those in a vault, they better be preserved, right? If something goes wrong, there goes your money. Right? So, and of course, there are many other schemes that have been created. Okay, I created an easy one that you can try with the IBM platform, but of course there are other schemes that you can that do not require a bank. That they actually can done by the public. Those are a little more complicated, but I just wanted to give you a little taste of of quantum money, right? Very simple, because you can actually try this one, right, in your own computer or your own phone, right? I'm using a cell phone deliberately just to say I'm using a phone, right? Imagine all that time that you spend at Starbucks, or I don't know, whatever you do with your phone. And instead you start actually, playing with the circuit. It's very easy. Try to come up with your own schemes, right? You might be one of those that comes up with a more useful way to apply this idea. Okay, this is just tip of the iceberg, right? It's just a brand new field. Um, and you can actually look at papers how some people have come up with their own schemes. You can come up with your own scheme, right? And you don't have to worry about the math, because you can actually run a lot of this stuff, right? As you can see, right? You can actually make sure it is you don't have to calculate anything. Although, to be honest with you, I had to do a little bit of calculations, because I like to think in terms of math like that. I'm used to that, old fashioned. Like to use the, the whiteboard and actually calculate things, but you don't have to, right? Because you can right here it does it for you, right? And you can see the results that you obtain. And like I said, if I hit that button right there, run, I actually can run this one. It takes a little bit of time, so that's why I'm not doing it. But this is just to give you a little taste of what quantum money will be in the future, right? Okay. So, well, it was fun being with you, and remember, quantum mechanics is fun. And for those of you who are about to quantum, we salute you. See you next time.